Okay, it's okay. We'll do it again because I want you to write the notes in the class. I'm not sure if you will have time to watch the recording and do it. We've already understood all this. It's okay. Okay, we'll just do it again. So this one is if two intersecting chords of a circle make equal angles. Okay, what is this? This is exercise 9.2. 9.2, the first example. If two intersecting chords of a circle make equal angles with the diameter passing through their point of intersection. This is the point of intersection of the two chords. And if it's the diameter, if it meaning the diameter passes through the center of the circle. Look at this. If two intersecting chords of a circle make equal angles with the diameter should pass through their point of intersection. Diameter should pass through the center and also pass through the point of intersection. Makes equal angles with the diameter passes through the center, diameter passing through their point of intersection. So the diameter passes through the center and it should also pass through the point of their intersection, right? Okay, so it is like this. So you see this is a diameter because it passes through the center, and this diameter also passes through the point of intersection of the two chords. Okay. Now, these two chords make equal angles with this diameter. These two chords, they make equal angles with this diameter. So that means angle 1. See, this is one chord. This is the diameter. So this is the angle between the chord and the diameter. Again, this is an angle between, this is the angle between the second chord and the diameter. Given that angle 1 is equal to angle 2, we need to prove that the chords are equal. Chords are equal. See, we'll do it faster now. Circle, two intersecting chords, point of intersection of the two chords, center of the circle. This is the diameter passing through the point of intersection. And of course, through the center of the circle, because it's diameter. So this is the angle between the diameter and one chord. This is the angle between the diameter and the other chord. And these two angles are equal. Given this, you need to prove that the chords are equal. You need to prove that chord AB is equal to chord CD. I have told you that the default construction is to show the perpendicular distance of the chords from the center. Okay. Show the perpendicular distance of the chords from the center. And also we don't have triangles. We need to somehow make triangles, right? So, and this is the default construction, dropping perpendiculars from the center to the chord. Okay, so here we have two triangles, and these are perpendiculars from the center to the chords. Okay, so this is 90 degrees. So this is a right triangle. This one is also a right triangle. Both are right triangles. So how do we show that these two triangles are congruent? So both the triangles are right triangles. So R 90 degrees. Then this is the common hypotenuse, right? This is the hypotenuse which is common to both the triangles. So H, no, I'm sorry, it cannot be RHS because we only have angle 1 is equal to angle 2. So then it will be AAS, two angles on some other side. Because we have angle, let me mark this 3 and 4. So we have angle 1 equal to angle 2 given. Okay. And then we have angle 3 equal to angle 4, 90 degrees. And then we have, suppose I call this, just for now, I just call it OM. OM is equal to OM, common side. So we have AAS, two angles and some other side. Because for these two angles, the included side is for this angle, and this angle, this is the included side. For this angle and this angle, this is the included side. No. So we don't have these two sides equal. We have some other side, OM, equal to OM, common side. So AAS criterion, the two triangles are congruent. CPCT, we have this side equal to this side, right? CPCT, we have this side equal to this side, which means the distance of the two chords from the center are equal. What do you say about this line segment and this line segment? They are the perpendicular distances of the two chords from the center. So through congruency, we found that these two line segments are equal, which means the distance of the two chords from the center are equal. And we have a theorem which says that if two chords are equidistant from the center, then the chords are equal in length. So here we are not directly proving that the chords are equal. We're doing it through a theorem indirectly. Their distance from the center are equal. So the chords are equal. Please write down. Just zoom in to show the diagram. See, it need not be like, you can just draw it comfortably. You can draw along with me if you have difficulty in getting the diagram. I just widen the, see, this is very narrow, no, here, so it looks very congested, the diagram. So you can just widen that space between the two chords. See here, like this. So now you can comfortably draw the center. These are the two intersecting chords. For those who want the diagram, can see again. See here. These are the two intersecting chords. Just widen the space. Okay. Then point of intersection center. So this is the diameter, correct? This is the diameter, right? Wait, look at the bone. This is the diameter. Okay. So now center perpendicular to one chord, perpendicular to the other chord. Now this angle is equal to this angle. This is the figure. This is angle 1 equal to angle 2. Okay, let me see if you understood the diagram correctly. Name the two chords in the figure. Both are the same. Both the figures are the same. Name the two chords. A, B, and C, D. Where do they meet? At E. They meet at E. The point of intersection of the two chords is E. Name the diameter. PQ is the diameter. PQ is the diameter passing through the point of intersection of the two chords. Which is the perpendicular distance of chord AB from the center? OL. OL. OL is the perpendicular distance of chord AB from the center. And what is OM? No, he's not able to see. Just move. Come to the middle. Okay now? Shreya, you also. Is it fine now? Yeah. What's OM? Perpendicular distance of chord CD from the center. That's it. Yeah. Yeah. Complete the proof. I didn't have space here to number the angles. You can number it also. You can call this 3, you can call this 4 and say 3 is equal to 90 degrees. Because I didn't have space, I just named it OLE and OME. Completed? Yes. Yeah. Done? Yeah. Right? Okay. One more line. Implies AB is equal to CD. Next one. This we didn't do in that session where we did the other questions. Two circles of radii 5 centimeters and 3 centimeters intersect at 2 points, and the distance between their centers is 4 centimeters. So two circles, one of radius 5 centimeters, another of radius 3 centimeters. They intersect at 2 points. Okay. See, these are circles that intersect at only one point. They intersect at only one point. These circles don't intersect at all. Even these circles don't intersect. Concentric circles. Need not be concentric, like one inside the other, like this. So these circles have no point in common. These circles have no point in common. These are called touching circles. They have exactly one point in common. Touching circles. They are not intersecting circles. They are touching circles. They have only one point in common. These are intersecting circles. Okay, touching circles can be circles that touch externally like this, or circles that touch internally like this. Touching circles can be two circles that touch internally or externally. Externally like this, internally like this. Intersecting circles. They have 2 points in common. So there can be two or more circles with no point in common. There can be two or more circles with no point in common, no point in common, like this, no point in common. There can be circles with only one point in common, like this. They are called touching circles. They can touch internally or externally. And lastly, we have intersecting circles, which have 2 points in common. They intersect. See, these are the points of intersection. So here in the question, the two circles are intersecting circles. Two circles of radius 5 centimeters and 3 centimeters, they intersect. So these are the points of intersection. At 2 points and the distance between their centers. This is the center of one circle, this is the center of the other circle. And the distance between the two centers. See, we don't know, like we're just assuming so, see, this is the center of one circle. The center of the other circle can be here also. We don't know, but we cannot assume that, so I'm taking it here. Okay. 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 Center. The distance between their centers is 4 centimeters. And see, if I join the center of the first circle to this point on the circumference, that's a radius, right? Yes. 5. If I join the center of the second circle to this point, see, this point lies on both the circles. This is the radius, right? 3 centimeters. All right? Yes. Okay. So here we have the answer. Okay, what's the question? I didn't read that for you. Find the length of the common chord. Find the length of the common chord. Common chord is this one. The line segment joining the points of intersection. The two circles intersect at 2 points, right? So the line segment joining the 2 points is the common chord. All right. So this is the common chord. We need to find the length of this common chord. So what we can do is we'll find the area of this triangle using Heron's formula. Easy, right?
Yes.
We know the sides 3, 4, 5. We'll find the area using Heron's formula. Now that area is equal to half base into height. Okay, I'm just thinking, area 6. Okay, area 6. So half into base 4 into this altitude, h, is equal to 6, right?
6. Yes.
We found the area already using Heron's formula. It is 6. Now we'll use the formula half base into height. For the same triangle, when you use the formula half base into height, you should get the same answer, 6, right? So half base into height is equal to 6. Half into, when you take 4 as the base, into this height, the height or altitude corresponding to this base is this one, is equal to 6. So 2 1 the 2 2s are 2h is equal to 6, h is equal to 3. H is equal to 3. So actually, you know what it means? This one, this is 3, right? It's actually, this one is, the radius is nothing but, this one is actually, this point coincides with this. That is the common chord is the diameter of the second circle. The common chord is the diameter of the second circle. Okay, but that's got nothing to do with the working. So h is equal to 3. H is equal to 3. Now this is the chord. This is the chord, right? So there's a theorem which says that the chord is bisected at this point. So if this is 3, this is also 3. So 3 plus 3 is 6. The length of the common chord is 6. The length of the common chord is 6. Please write down. As you write, you may get a few questions to be clarified. We'll do it. Now you just start working.
And they give me this one as homework, and I don't know what to do. So I just draw two circles with 5 centimeter and 3 centimeter.
Separate circles, huh?
No, not intersecting.
Okay.
And the common chord, I just do a line and just measure with measure mark. I get 6 centimeters. For one more, can we use that? Use like that?
Yeah, 1 mark your teacher cannot make out. Yeah.
For 5 mark, we do practice. For 1 mark, it may take long.
Correct. Yeah, okay. You should be so fast in drawing. Draw a circle with radius 5, then with the center measure 4 centimeters distance, then put your compass there, take 3, and then, yeah, you can.
Miss, can the touching surface can be 50% internal and 50% external?
That's what has happened here. So you can also draw the diagram like this. You don't have to see here. See here. You can just draw it like this. See here. Look at this figure. Now this looks a little difficult to draw, so leave this. So, and this point is M. This point is M. Please draw this figure. All of you, please draw the figure and the zoom in. So which is the center of the first circle or the bigger circle? O. And the center of the smaller circle? O dash. Where do the two circles intersect? Where do the two circles intersect? A and B. The two circles intersect at A and B. Which is the common chord to the two circles? AB. The line segment joining the points of intersection. A and B are the points of intersection. A and B are the places where the two circles meet. When you join those 2 points, that is the common chord. Common chord. And what is OA? Radius of the first circle. OA. Radius of the first circle, 5 centimeters. O dash A. Circle. Radius is 3 centimeters. And what is O dash? The distance between the centers of the two circles. O dash is the distance between the centers of the two circles. 4 centimeters. That's given. The distance between their centers is 4 centimeters. Okay, again. Name the line segment that represents the radius of the first circle. Line segment that represents the radius of the first circle. OA. Line segment that represents the radius of the second circle. O dash A. Which is the line segment that represents the distance between the centers? O dash. O dash. Not O and O dash. O dash. It's a line segment. O dash. O dash is the distance between the centers. Where do the two circles intersect? At A and B. At A and B. And when you join AB, what do you get? The common chord to the two circles. The chord which is common to the two circles. And what is M? M is a point on AB. That is, M is the point of intersection of O dash and AB. O dash and AB, they meet at M. O dash and AB, they meet at M. Understood the figure?
Yes, ma'am.
Navneet.
Please can I use this?
Yeah. Yeah, completed, all of you? Okay. So first we find the area of triangle O dash A, correct? Area of triangle O dash A. What are the sides? 3, 4, and 5. OA is 5, O dash is 4, and O dash A is 3. So using Heron's formula, we find the area of the triangle, which is 6 centimeters square. Now half into base O dash into altitude AM is equal to 6. So with that we get AM is equal to 3 centimeters. Now AB is equal to twice AM. So 2 into 3, 6 centimeters. Now how do we use all these results? AB is twice AM. That's because there's a theorem which says that AB is the common chord, right? And what is O dash? It's a line segment joining the centers. Now this line segment joining the centers of the two circles, it is the perpendicular bisector of the common chord. AB is the chord common to the two circles. And what is O dash? It's a line segment joining the centers. Now this line segment joining the centers, O dash, that one is the perpendicular bisector of the common chord AB. So say this is AB. This is the common chord AB. This is O. Okay, so this is O. And say this is O dash. This is O dash. Okay, so this is the line segment joining the centers, O dash. All right. Okay. AB is the common chord. O dash is the line segment joining the centers. Now this O dash is the perpendicular bisector of the common chord AB. That means the angle here is 90 degrees, and also M is the midpoint of AB. M is not the midpoint of O dash. O dash bisects AB. O dash is perpendicular to AB. Let me write that. O dash is perpendicular to AB. O dash bisects AB. Who is O dash? The line segment joining the centers. That one is perpendicular to the common chord AB. It makes 90 degrees with AB. And that O dash also bisects AB. AB is the common chord. O dash is the line segment joining the centers. Now, according to a theorem, O dash is perpendicular to AB. That means it makes 90 degrees. Also, O dash bisects AB, cuts AB into two equal pieces. And by this figure, the two equal pieces are AM and MB. So we found AM 3. So MB is also 3. That's why AB is 2 into 3, 6 centimeters. The length of the common chord is 6 centimeters. Okay, so the procedure here is to get the triangle, to draw the figure and identify the triangle, find the area of the triangle using Heron's formula, equate that to half base into height to get the altitude AM, and double that, which will be the length of the common chord. So if two equal chords, you can see the figure here, two equal chords of a circle intersect within the circle, prove that the segments of one chord, see I've marked it here. These are AB is one chord, right? AB is one chord. AE and EB are the segments of one chord. Similarly, DE and EC are the segments of the other chord. It's here. AE and EB are the segments of one chord. DE and EC, correct?
Yes.
Are the segments are two pieces of the other chord. Okay. If two equal chords of a circle intersect within the circle, prove that the segments of one chord is AB, one chord is AB, and AE and EB are the segments of that one chord AB. And the other chord is CD. The segments of CD are DE and EC. Prove that the segments of one chord are equal to the corresponding segments of the other chord. So corresponding segments will be this small one. AE corresponds to DE. AE of one chord corresponds to DE of the other chord. Then CE of one chord corresponds to EB of the other chord. You need to prove that these two segments are equal. Okay. So this is the diagram. This is the diagram. And so to see all this, we join OE here to get two triangles. See, actually the diagram is just this. The other things we have to do by ourselves. The diagram is just this. Two chords intersect within the circle. You will have to prove that this one is equal to this one and this one is equal to this one. That's all. This is the diagram. Then how do we get this diagram? That's because you need triangles. So circle's default construction, dropping perpendiculars from the center to the chord. That's a default construction. Draw perpendiculars from the center to the chord. Still we don't have triangles. So we join this. Now we have two triangles. Right? Okay. Circle. Okay. Drawing perpendiculars from the center to the chord. That's one thing. And then we join this to get two triangles. So now we show that these two triangles are congruent. And CPCT will have ME is equal to NE because ME is a side of this triangle. NE is a side of this triangle. When you show that these two triangles are congruent, their corresponding sides or corresponding angles will be equal. So now we have to take we'll have to write the most relevant information. So let's write ME equals NE. I've marked it yellow. Okay. That is, see, you can see ME is a line segment of the first triangle. NE is a line segment or a side of the second triangle. So these two line segments or these two sides are equal CPCT. Next, what you have to do is, I think I have it here. See here. See here. You have to start again. Now, triangle congruency CPCT. That's one part. That's over. Now we are starting, our next part. AB is equal to CD. Yeah, because it's given equal parts. Half AB is equal to half CD. Yeah, because when you know the midpoints of the chords, then you can use this half AB, half CD. Because we have drawn perpendiculars from the center to the chords, we know that the perpendicular from the center to the chord bisects the chord. So M is the midpoint of CD, N is the midpoint of AB. Okay. So what is half of AB? Half of AB is AN. And what's half of CD? Half of CD, DN. DN. Why did we write those portions? Because we have, we have ME equal to NE, right? So ME extension is like MD, right?
Yes.
And NE extension is AN. So we want to write those segments. This is written very consciously. See, you can write the other piece also. I'll tell you what to do. If you write that, what to do, I'll just tell you in the second part. Now, AB is equal to CD, half AB is equal to half CD. Okay. Now, half AB, you write the extension of ME, that is DM. Oh no, half AB is here. N is extension AN. And half CD, where is CD? This is CD. So we have ME extension DM, right? DM. Okay, because M and N are the midpoints of the chords. Because the perpendicular from the center to the chord bisects the chord. Okay. Now you subtract that result. Now we have a result, right? We've just proved something by CPCT. ME is equal to NE. Write that carefully. Like NE is a part of AN. NE is a part of AN. So under AN, write NE. And ME is a part of MD. So write it carefully one below the other. This is the result we got through CPCT. This is half AB, half CD. And that result by CPCT. Okay, now when you subtract AN minus NE, AN minus NE is AE. And DM minus ME. We're subtracting the two results. DM minus ME is DE. So we proved that these two segments are equal. AE is equal to DE. AE is equal to DE. We have to prove that the segments of one chord equal to segments of other chord, right? So one part we proved AE is equal to DE. This segment of the first chord is equal to the segment of the second chord. Now, to prove the second a pair of segments are equal, write this one. AB is equal to CD. And write this result which we just proved. AE is equal to DE. AB is equal to CD. Now this result which we just proved. AE is equal to DE. Now subtract AB minus AE. AB minus AE is BE. And CD minus DE. CD minus DE is C. So we proved that the corresponding segments are equal. So what if you write CM, if supposing you write CM, that is the triangles are congruent. So ME is equal to NE, right? Are we okay till here? ME is equal to NE CPCT, correct?
Yes.
ME is equal to NE CPCT. Now below this, if we write, here, this I'm coming here, AB is equal to CD, half AB is equal to half CD. Now for half AB, if you write BN, and for half of CD, you write CM. Okay. Now write the CPCT result below it. Now below BN, what should I write? Below BN, NE, should write NE equals below CM,
Yeah.
ME. Now add these two results. What is BN plus NE? BN plus NE. BE is equal to what is CM plus ME? CE. Yeah, so you can still go. So there's nothing like you should not write. Then you should add. If you write that half, you should subtract. You write this half, you should add. Add the CPCT result. You can write any half of AB and CD. When you write one particular half, you should add that and CPCT result. If you write the other halves, you should write that and CPCT result and add. You add or you subtract, depending on which halves you have written. So you got BE equals CE. Now to get the other one, AB is equal to CD. Now write this result. BE is equal to CE. Now what is AB minus BE? AB minus BE, AE equals CD minus CE. D. This is the other one. Okay. Okay. Right. Write on the proof. No, the diagram so annoying for me. So little. Draw this diagram. No? Please take this diagram. Okay. Write down the statement, draw this diagram. Okay, I'll give you the proof. Ready with the diagram? No, don't draw again. It's the same thing. All right. Okay. So given chord AB equals chord CB is the point of intersection of AB and CD. To prove that AE and EB are the segments of chord AB. DE and EC are the segments of chord CD. To prove that AE equals DE and CE or EB. EB equals EC. Construction. Draw OM perpendicular to 1 minute. Like, can I change this to, can you just change this to M? Because AB first, no? So we'll draw on AB first and then kindly change this alone, no? M and please change the positions. M and N alone. Online children, please make a note of this. OM, M is on AB, N is on CD. Please change that. So draw OM perpendicular to AB and draw ON perpendicular to CD and also join OE. In triangle OME and triangle ONE. Angle 1, angle 1 is equal to angle 2, equal to 90 degrees. That's R. Then OE equal to OE, common hypotenuse. H. R, this H. And ON. OM equals ON. Because after also join OE, isn't trying to close the place to is in triangle OMB and triangle OMB, that's proved, right? That's proof. That's a proof, yeah. Yeah, this is the proof. Yeah. Therefore, triangle OMA is congruent to triangle ONE by the RHS congruent criterion. ME is equal to NE CPT. Yeah, how do we proceed after this? Now we should start, I told you again, now we should start by writing AB equal to CD given. Okay, so we'll do it in both the ways. AB is equal to CD given. Half AB is equal to half CD. Half AB is equal to half CD. So half of AB half of AB. What is half of AB? AM or MB. Okay. So here we'll write AM. Here we'll write MB equals half CD. Half CD is DN or NC. But where you've written AM, you should write DN. See, half AB you've written AM, right? Therefore, half CD you should write DN. Here you should write DN. And here for half AB you've written MB. MB. So you should write CN here. For half CD, you should write CN. Correct? Okay. So now we have, so here we have AM equal to DN. And here we have, what is it? MB is equal to NC. MB is equal to CN. Okay. Now we have a result with us, no? CPCT result. ME is equal to NE. Where is ME? ME is on AB. Okay, so write it carefully. ME. So you should write ME here because this is of AB. ME is equal to NE. NE. ME is equal to NE. So in one place you should add, in the other place you should subtract. So AM and ME. AM and ME. Here you have to subtract. Because AM and reverse ME. What is AM minus ME? AE. So here you should subtract. Equals DN and NE. DN, NE is DE. So here you have to subtract. But here MB and ME. MB and ME. You cannot subtract, no? MB and ME, how can you subtract? So you have to put them together and write EB. EB equals CN and NE. CN and NE is C. So you can see we proved, these are two different results we proved. Now you must write the whole line, meaning the whole chord. AB is equal to CD. Here also write AB is equal to CD and subtract these results. AE is equal to DE. This you should subtract in both the cases. EB equals B. So AB minus AE, AB minus AE is BE equals CD and DE. CD, DE is C. AB minus EB. AB minus EB is AE. CD and CE. CD, CE, DE. So the thing is here, this result you got here, but that you're getting it here. இங்க இந்த ரிசல்ட் ஃபர்ஸ்ட் வந்துடும் அப்புறம் தான் இது வரும் இங்க வந்து இது ஃபர்ஸ்ட் வந்துடும் so you should do it by yourself then now you understood right yes this is what it is write down or okay you can do it not like this but you write down both alongside like this like a comparison write both Completed, all of you?
Yes, yes.
Online children, completed?
Yes, ma'am.
Okay. Circle, two chords, not equal. Two chords, they intersect inside the circle. Prove that the line joining the point of intersection to the center. This is the point of intersection, this is center. And this is the line joining the point of intersection to the center. This line makes this is the point of intersection. This is the center. This is the line segment joining the point of intersection in the center. You need to prove that the line joining the point of intersection to the center makes equal angles with the chords. So this is the angle between one chord and that line segment. And this is the angle between the other chord and the line segment. You need to prove that these two angles are equal. Prove that these two angles are equal. Angle 1 is equal to angle 2. And it's given that they are two equal chords. AB and CD are two equal chords. So listen, AB and CD are two equal chords. They intersect inside the circle at the point E. EO is a line segment joining the point of intersection E to the center O. We need to prove that angle 1 equal to angle 2. So the default construction is to draw a perpendicular from the center to the chord. So draw OM perpendicular to AB, draw ON perpendicular to CD. Now, since they're equal chords, their distance from the center are also equal. So OM is equal to ON. Because AB is equal to CD, OM is equal to OM. So it's very simple. No, you just have to show that the two triangles are congruent. So angle 1 is equal to angle, angle 1 is equal to angle 2 is what we have to prove. Okay. So let's mark it 3 and 4. Angle 3 is equal to angle 4, 90 degrees by construction. R. H is OE is equal to OE, common side. That's H. S is OM equals ON because equal chords are equidistant from the center. So RHS rule the two triangles are congruent. CPCT, angle 1 is equal to angle 2. Right on? I'll mark angle 1 here. I'll mark 1 here. Okay, I'll just change the numbers. Sorry. 1, 2, 3, 4. Completed? Okay. Completed on children?
Yes, ma'am.
Okay. If a line intersects two concentric circles, okay, if a line intersects two concentric circles with center O at A, B, C, D, you should write it in order, or you should write A here, A, B, C, D like this. Okay. Because when you draw the line, how does it enter the circles? Like it comes. So see here. So when you start here, how does it cut? It meets that line segment, it touches this circle, then it touches here, then here, and then here, right? So that order, A, B, C, D. And this is the center. So if a line intersect, okay, it's a line. Let me show you a line 1 second. If a line, so say line L. It intersects these two circles at the points A, B, C, and D. So say with your mind, please prove that AB is equal to CD. Prove that AB is equal to CD. All right? Okay. So I'll just write and explain. So given two concentric circles with center O, with center O, line L intersects the circles, intersects the circle, I'll just continue here, intersects the circles at A, B, C, and D. To prove that AB is equal to CD. Construction, always draw perpendicular from the center to the chord. Okay. Construction, draw OM perpendicular to L. Perpendicular to L. Okay. Okay. Now the proof. We'll write the theorem we are going to use first. The perpendicular from the center to the chord bisects the chord. Bisects the chord. This is a theorem we're going to use, okay? This is a theorem we're going to use. Now, OM, the OM is perpendicular to chord AB, right? AD. OM is perpendicular to AD, right? What is AD? It's a chord. And what's OM? It's a perpendicular from center to the chord. OM is a perpendicular from the center to the chord AD. So it bisects the chord by the theorem. OM is perpendicular to chord AB. Okay, therefore, by theorem, OM bisects AD. This implies AM is equal to MD or AM is equal to DM. Okay, you can just call this result 1. Then OM is perpendicular to the chord PC. Therefore, by theorem, OM bisects PC. This implies MB is equal to MC. MB is equal to MC. No, I've written AM here, no? So I'll write BM is equal to CM. Therefore, BM is equal to CM. Now let's write these two results one below the other. Okay, so 1 minus 2 gives. 1 minus 2 gives. All right. What is 1? AM equals BM. And 2 is BM equals CM. Now subtract the two results. Yeah. AM minus BM is AB equal to BM minus PM. You see. Hence, right? Oh, so sorry. Completed?
Yes,
Done? Online children, completed?
Yes, ma'am.
Okay. 3 girls, Reshma. So till here we had already completed. Okay. But this effort, I'm not sure if you would have taken it home. It's not a waste of time. You heard it again, so doubly understood. So I think it'll be easy for you to revise for your test or exam, whatever. 3 girls, Reshma, Salma, and Mandeep, are playing a game by standing on a circle of radius 5 meters drawn in a park. So you can see the figure here. This is circular park. Okay, this is circular park. Reshma, R for Reshma, S for Salma, and M for Mandeep. So these 3 girls, they're standing on a circle of radius of 5 meters, not centimeters. Okay, 5 meters drawn in a park. Reshma throws a ball to R throws a ball to S, and S throws to M, and M to R. So these little girls are playing like this. Reshma throws a ball to Salma, Salma to Mandeep, and Mandeep to Reshma. If the distance between Reshma and Salma, if the distance between Reshma and Salma, R and S is 6 meters, I'm sorry, it's meters, okay, everywhere it's meters, children, okay, and the distance between Salma and Mandeep is 6 meters. Salma and Mandeep is also 6 meters. What is the distance between Reshma and Mandeep? What is the distance between Reshma and Mandeep? Circular park, center, radius 5 meters, radius 5 meters. Reshma, Salma, Mandeep, Reshma to Salma, Salma to Mandeep, Mandeep to Reshma. Okay. Center of the circular park, O. Radius is 5 meters. Radius is any point joining radius is any line segment joining the center to any point on the circumference. So if you join O to S, radius. O to M, radius. O to R, radius. Because O is the center of the circle and R, S, and M are 3 points on the circumference of the circle. So OM radius, OS radius, OR radius. Okay. Okay. 6, 6. Distance between Reshma and Salma, Salma and Mandeep. 6, 6. Correct? Center, radius, how much? 5 meters. Radius, 5 meters. Okay. So we need to find the distance MR, the length of the line segment MR. All right. Okay. So you have to first, okay, this part also I think we have to prove. I've directly written here. We'll also prove this part because I don't know if the Okay. All right. Yeah, draw the figure. We'll do it together. Write on the question. Draw the figure. It's meter everywhere. Please don't write centimeter. It's meter everywhere. Just write the question, draw the figure. Don't write anything else. Okay. Yeah. Write this part first. Don't write this after the figure. Ready with just to draw the diagram. Okay, leave some space. Maybe I'll share the image on WhatsApp. You can complete it later. Written the question, all of you?
Yes.
Yeah, now let's start. So we start like this. In triangle, can you see SOR and SOM? SOR, SOM. In triangle SOR and in triangle SOR and triangle SOM. Okay. Can I say OR is equal to OM? Why? Radius. Yeah, radius of the same circle. Correct. Can I say OS is equal to OS? Radius. Yeah, common side. Common side. And can we say RS is equal to MS? 6. It's given 6 meters. It's given both equal to 6 meters. Therefore, triangle, if you say SOR, is congruent to triangle SOM. What's the criteria? Criterion by the SSS. SSS congruence criterion. The two triangles are congruent because everywhere side no OR is equal to OM, OS is equal to OS, RS is equal to MS. SSS criterion, the two triangles are congruent. So angle 1 is equal to angle 2, CPCT. Angle 1 is equal to angle 2, CPCT. I have written that directly here through some theorem. So just ignore that. Write this instead. So first we need to take up these two triangles, show that they are congruent and get the result angle 1 is equal to angle 2. Sorry. All right. Okay. Next, we have to take up finish writing. Yeah. Now, if you let me know, I can do the needful writing. Not clear? Okay. So after this, now we have to take up these two triangles. Okay, see this triangle. We have to take up this triangle and this triangle. Oh, sorry, we just finished that, sorry. Now we have to take up these two triangles. Sorry, we just finished it. This one, and this one. And show that they are congruent. That also we have all the information here. In triangle RSN, can you see RSN, this triangle RSN and triangle MSN. In these two triangles, you can see RS is equal to MS. Why you're not listening today? You're busy writing. In these two triangles, RS is equal to MS, correct? Why 6 meters? Then angle 1 is equal to angle 2, we just proved. NS is equal to NS, common side. In these two triangles, RSN and MSN, RS is equal to MS 6 meters. Angle 1 is equal to angle 2, prove, and SN is equal to SN. So it is two sides and included angle. Two sides include angle. Here, this side, angle 1, this side, and angle 2. SAS, congruence criterion, the two triangles are congruent. So, through this congruency, we're going to say that this angle is equal to this angle. This angle is equal to this angle. But they form a linear pair, right? Yes. So, this angle is equal to 90 degrees. This is what we wanted. For this 90 only, all this drama. 19 சொல்றதுக்கு all this. So, in the second set of triangles, we'll say that this angle is equal to this angle, CPCT, but they form a linear pair. So their sum is 180. So you know this procedure, no? See at RNS, see this RNS is this angle plus MNS is this angle is equal to 180, but they're equal, no? So RNS plus RNS is 180, twice RNS is 180, RNS is 90. Okay. This angle is 90 degrees. All right. Which means everywhere is 90. This is 90, this is 90, this is 90. Now we are done. Now it's very simple. Can you see the triangle MSO? MSO. You can take any triangle. You can take MSO or you can even take RSO. MSO or RSO. Anything. MSO. Or you can take RSO. Now in MSO, you know all the sides. Check. MS is 6. SO is 5 radius. And OM is 5 radius. In this triangle, you know the lengths of all the sides, all the 3 sides. So you can find its area using Heron's formula. And you see here, it's 12. See, here in this triangle, you know the length of all the 3 sides. So find the semi-perimeter. Heron's formula, area is 12. Now, the area of this triangle, which is called SOM, the area of this triangle is 12 meters square. Can you see Mn is the altitude? Can you see that? Can you see this figure? See, this is the triangle whose area we have found, 12 meters square. And this is the altitude. This is the altitude. M is O triangle and Mn is the altitude, correct? So we found the area of the triangle is 12 meters square. Now the same, equate this to half base into height. Half into base OS. Can you see the base OS? Into altitude Mn. Because Mn is altitude on SO, right?
Yes.
So half into base SO into altitude Mn is equal to 12. But how much is SO? SO is the radius, it's 5. So working with that, we get Mn is equal to 4.8. Mn is 4.8. Mn, this one is 4.8. Yeah, and I didn't say one thing. CPCT should also write Rn is equal to Mn. We proved that these two triangles are congruent, right? You should also write this result Rn is equal to Mn. So now you got Mn is 4.8. So Rn is also 4.8. So Rm is equal to 4.8 plus 4.8, 9.6. Okay. All right.
Yes.
Yeah. Complete this. Completed? Board பார்த்தே இந்த புக்கு பார்க்கவே இல்லை. Completed? You finished. What were the others? Completed online children?
Yes, ma'am.
Okay. Now, since it's time, I was working in different ways. Actually, like 5 minutes, why don't you just write down this fast? Or shall I share the image on WhatsApp? Will you complete this? I want you to finish writing this in your book by the next class. Will you do that at home? Do you want to do it now? Do it at home. Yeah. Okay, I'll share this image on WhatsApp. Please complete this. We'll see the explanation in the next class. All right. All right, children. So that's it for today's session. Online children, you may leave the call. Thank you. Thank you, children.
Thank you.
Thank you.